Okay? So we have a panel of esteemed experts. Thank you so much, everyone, for joining me. Wonderful speakers. And everyone, we have a special guest as well. So hello. This is Emil. He is the CEO and founder of... He's joining us today, Emil. Let's give him a round of applause. Woo! Excellent. Okay, so today this is such a special panel. I'm so glad everyone's here and is going to be able to capture this. So the first question that I have for you now, right? I think that we have to get some common vocabulary going before we dive in, right? So just to level set for that common vocabulary, I'd love to hear from everyone on the panel and Emil as well. We are going to start with, can you articulate for us? And can you help us understand what the difference is, and specifically what the difference is between a context graph and a knowledge graph? What's the difference there?
Wet water.
There we go. Say more.
I mean, in my opinion, it is. I know that we're still trying to define an industry, but I'm going to say it is a knowledge.
Yeah, I mean, terminology definitions forever, and of course, it's valuable to have some understanding of terminologies that we, on some reason, about the same kind of things, right? To me, it's simple. A knowledge graph is a superset of a context graph. Graph is you take your data in your domain, press it in a graphy form, and Will showed kind of the pole plus or whatever, people, organization, location, event, and objects. That's one expression of a knowledge graph. And then in that case, you have the context graph, which is kind of the decisions that are then added on top of it. You want to connect the decision traces to the your knowledge graph, right? So that's kind of at the high level how I look at it.
Yeah, and I think just to reiterate this idea of overloaded terminology, I mean, the word context is so overloaded, right? We use it to talk about a specific text that we inject into the LLM's prompt, right? We call this like the context window. We as relationships, the metadata, like all of these things like are very overloaded. And this is, I talked about the near agent library in my talk, and this is one of the choosing. What are the abstractions that we want to expose? And you read the literature on this, and it's like semantic memory, episodic memory, procedural memory, user probably like what's the difference, right? And so I think trying to go with short-term, long-term reasoning, and I think that a lot of like what folks are trying to address. So anyway, like I just reiterating, like yes, this terminology, people mean lots of different things when they say context, knowledge, all of these things mean different things to different people. And so yeah, something definitely to be aware of when you're building tooling as well to think of.
Yeah, I think on my side, I like to describe context graphs sum of two different graphs, both knowledge graphs and the graphs of action and procedures. So you just put those two graphs together, and in the end you have the context graph to guide the decisions of the agents.
So I'd say when that foundation capital paper came out, that it actually caused quite a bit of, our CEO was like sent it out to all of us like right away, and we were all like, it spurred debate. And so I think the water that really resonated with, but I think for me, it's more like the knowledge graph is a superset of the context graph is really more like any sort of extra dimensionality rather than like, that simple triple. And that extra dimensionality could be the decision trace, or it could be, data provenance about some of the properties that are involved there. I don't think there's like this like rigid box it fits into, but I think the nuance is just the extra dimensionality.
See, and that's why I really appreciate making sure that we have that common language, right? That common conversation. Because so many people do define it in so many different ways. And in many ways, it is a water is wet. And for those of us who've been in the knowledge graph and context graph space for so long, like this is not a new concept, right? So trying to make sure at least when newer people are coming into the field and coming into the conversation that we're at least having the same kind of conversation at the same time. So I also want to then move forward with the understanding like there's so much excitement that's happening right now, right around context graph. And some might argue that this concept has been around for decades, right? And then, and some might call that as knowledge management, just like Jessica had mentioned as well. But I want to take a step back. I want to take a step back and thinking about making sure that the audience can understand why is this concept so pertinent right now? And I don't mean just right now this month, right, or the last few months. I mean within this larger history of agentic development. Why now for context graphs?
Yeah, I think so. Everyone sees the benefits of the context graph, and it's a concept that has been for a decade or more. And so why right now it has huge momentum is thanks to the latest LLM, Gen AI advances, you don't have anymore the drawbacks that you had before on initial setup, on maintenance, updates, things like that. You can automate a lot of things regarding that, so you are erasing a lot of drawbacks that you had before. So you keep the benefits and you don't have the drawbacks that you had before. So I think it evolved. It's kind of the past to build manually those graphs and so on. So now we enter into a new era, a new generation on how to do that. And so happy to do that together.
Yeah, I agree with that. I think it's funny, right? Remember last year was supposed to be the year of agents, right? And no, specifically agents in production, right? That was what last year. And then I think Andrej Karpathy gave a talk at YC saying, actually, it's more like the decade of agents in production, right? And I think he was very right in that. I don't think we saw certainly agents go into production last year, but by and large, it's very, very early still. And I think what context graph, what that blog post did, and I think in a really eloquent way, was that it established or popularized this terminology for something that I think is a really central part to make sure that agents actually work in the real world. I think there's, broadly speaking, 4 sources, 4 buckets that agents require to be useful in production. They need access to the system of records, so that is the present state of your organization, right? This is your CRM systems or what marketing systems, all that kind of stuff, right? They need access to your data platform. So this is, I always think of this as system of record for history. So this is your Snowflake or your Databricks, your data warehouse, that kind of stuff. They need access to the agentic memory. What is the conversational state, the session state for your agents? And then now we have a term for this other piece, the decision traces, the institutional knowledge encoded in some way as the 4th piece. And I think what's emerged now is that you give your agents access to those 4 pieces, right? That is sufficient data, sufficient knowledge for them to actually work in reality in production. So I think if many of us have written similar things to what the Foundation Capital guys did, like 3 years ago, 5 years ago, 7 years ago. I feel like I've been saying the same damn things for 20 years now, right? In so many ways, right? But I think it's a little bit how they wrote it, but also like this moment in time and this really central piece of information that is required as part of the underlying substrate for making agents work in reality. So I think that's probably why it grabbed like all this attention.
Okay, I'm going to draw it out a little bit, sort of a wider lens. Is also workflows. I think that's just a common element that most people are dealing with is workflows, and they're trying to automate workflows. And so this is a logical step towards doing so reliably. And I think that crosses. The other thing is it crosses industries, and it crosses environments. So it's something that's easily relatable.
Do I have to pay you later, or? I feel like that was set up for us. I couldn't agree more. To me, though, it was the timing was right? Like it was like that paper dropped at like the exact moment. Like Emil said, it's like it was supposed to be the year of the agent, but everyone's you got so far, and then that paper just made so much sense, and so it hit the nail on the head, I think. New word and everything.
There was a study a few months ago, I think from MIT or something, that said that 95% of AI projects fail to deliver value, right? And I think the reason for that is the data problem, right? Like in this case, agents don't have access to the right data, and so those projects are failing, and now folks are going back and sort of re-architecting this and realizing, okay, well, if data is the issue, what do we do at the data layer to provide the most relevant data, most relevant context for our agent? And so I think a lot of people are struggling with this problem of how do I get the right data to my agent as they're introducing agents to help with workflows and help augment human knowledge work, right? Essentially, we want these agents to help employees be more productive is sort of how I think it's going. And I think what folks are realizing is like when they're trying to help the agent implement policies and make decisions, they're like, well, we don't even document and have like proper data on how the humans are making these decisions in an organization and doing that. And that was a big realization of like, oh yeah, we have all of these policies and data in different systems that maybe like as an analyst, your job is to go out and fetch those, or you build systems that interact with those. So I think that really resonated, and folks are going back on board and realizing, oh, I need to build my context graph on the, again, data from folks' heads that Jessica was talking about to represent that before I can expect an agent to give me a valid recommendation to understand how we do things now. So I think that's a big part of the timing as well.
And so moving away a bit about moving away from why context graphs really make a lot of sense for the now, right? I'd love to know, based on your analysis of the conversations that are being had around context graphs, what are you seeing is actually missing from this conversation?
Knowledge management.
Say more.
It's like an elephant in the room. I mean, no, it's something we want to automate so badly, and we've never really taken responsibility for organizing our actual knowledge, yet we cry when humans are automated. Like when the human process is automated, I don't really have a solution for that necessarily, because it needs to be a relationship between humans and machines, but it also needs to be an investment from organizations. It just needs to be. We've avoided it. It's something that organizations have not invested in up until now, and I think we're at sort of a crux where we aren't going to really have an option. I just bring down the party. Sorry.
No.
Okay.
Not at all. Not at all.
I think that's totally fair. I mean, I spend a lot of time in organizations, and I'm sure everybody in this room does too, and nobody ever wants to do that work. People don't keep track of things. People, at the end of the day, it's a human problem will limit how far this can go. And until the hard miles, I think, are walked, I think Jessica's kind of bang on.
Yeah, and a part of the reason why I ask a question like that is because I think it's so important when we're having engineering teams, right, that are actually building out context graphs. We want to make sure that we are having a comprehensive understanding of the problem, right? The comprehensive understanding of how do we build out and implement knowledge graphs into our systems, and in ways that speak to, or at least involve different frameworks, right? Ontologies, just like you mentioned, different frameworks that will help this process become more effective in the long term. So that's just a little bit of the reason why I want to make sure that we're also hitting upon what's missing in the larger conversation around context graphs right now, right? Even with all the excitement and the hype around it. What can we be laser focused on in making sure that we're solving this comprehensively? So yeah, perfect. Okay, so also, because of this larger reinvigoration, and don't worry everyone, we're going to have time for questions from the audience too, so get those questions stirring up. But because of this larger reinvigoration, I'll say, around the concept behind knowledge graphs and the new focus on context graphs specifically within agentic development, I'm seeing a lot of the conversation be a little high level, right? So I want to dive into the I want to dive into the weeds. So, what does implementation of knowledge graphs, look at that, of context graphs look like within this space? And I know a lot of us have companies and have engineers who are actually building out context graphs right now. So what does implementation look like, and what should it look like? What advice would you give to engineering teams who are trying to build out context graphs right now?
Yeah, there's so many pieces to this, right? And I talked about in my talk. I talked about the Neo4j agent memory package that we built to try to enable recording things like your reasoning traces and these sorts of things. So I think that in my talk are most important around getting the entity extraction right, thinking about the data model that you're using for entity extraction to match your domain. Like this, I think is really key, is really important. But then it's a lot of things like how do you represent the canonical representation of some concept. These sorts of things to understand and make sure that your data quality in the graph is sort of where it needs to be. This idea of an entity resolved knowledge graph, I think is kind of the term for this. If you search online for what that is, you'll see some of the techniques for creating an entity resolved knowledge graph. And like that problem doesn't go away with context graph. The challenge doesn't go away with using an LLM for entity extraction. Like you still have to reason about this and proper data modeling and things like this with your context graph.
I think the most phenomenal, if you guys have a chance to look in the GitHub repo of the PKO project, the Cephreal project, you'll see that there's a very cool package for knowledge elicitation. I know I hit on that during my talk, but it's a framework, and it exists as like a plugin for the browser for human users to be able to enter context about workflows in sort of a form. I am going to say that that's something that I've seen to be very productive and successful, is to involve humans, but also human verification. And to also note that there can be multiple workflows, especially if you have situations where a company has a lot of acquisitions. And so it may not be linear. I think that's really important, is to be kind of heads up that it's a little bit like a fingerprint.
Yeah, from a very practical use cases, we've seen a lot of people using MCPs to leverage context graph. So for example, something that works well we've seen is plugging an MCP into your IDE for coding, so that you can have a personal memory that stores how you code, what are the practices of your company, and so the MCP is both learning, so listening, and then serving the right context so that you have no regressions and it's coding how you like to code. So that's very practical implementation through MCPs. Maybe it will evolve, but today it's very, very practical and people use that.
So for me, I'd say, going back to what Will said, it's like getting the right data in the right place, in the right format, right at the right time. And but is it good data? A lot of our data is uncleansed, unwashed, and so being able to identify the things that can be used and segregating them from the things that can't be used is critical, I think, to success.
Yeah, if I think about what are the big things that have changed over the last couple of years after having spent a while focusing on how to build systems with graphs, I think there's maybe two things that are emerging, right? in the last couple of years, right? One is we did a ton more unstructured data than we did 3, 4 years ago, pre the ChatGPT moment, right? Because LLMs give us an ability to operate on unstructured data, right? So that's kind of one. And then the other one is more often than not, do our kind of execution layer, the agents, right, span multiple systems. Whereas 5 years ago, it was more common that an application sat on top, but it's like one system, right? And both of those, I think, just from a very practical perspective, that was the framing, like what's kind of the practical thing. One you mentioned, Will, which is because unstructured data is much more prevalent right now, entity resolution becomes much more important, right? So how do I go from, let's just think about text for a moment, like lots and lots of text to extract that into real entities. This is a node called Emil, right? And then there's like an Emil Eifrem, there's an Emil G Eifrem, there's William Gates and Bill Gates, like named entity recognition. There's different terms for that, but like how do you go from all that into like this is a node, right? So that's a really fundamental capability that existed 10 years ago. You mentioned entity resolved knowledge graphs, like sensing, Jeff Jonas, I talked to him about this 15 years ago, 20 years ago. So it's been around, but it's way more important today compared to 2 years ago.
And I just published an article about forming it into RDF.
There you go.
I did with sensing.
Okay,
The
with
project for
Jeff's
sensing.
team. Yeah,
And
yeah.
we published the that makes it so that you can transform into ontology.
So I think so. That's one thing, and
Yeah,
then the
yeah,
second
yeah.
thing is what you just
Yeah.
mentioned, and you even said the O word, or maybe you said the other word, right? Which is, so ontology has been this word that I personally try to avoid for 2 decades, right? Because it just brought in this notion of complexity. And one of the problems the graph world has always been plagued with is that we love our fancy terminology, right? And I personally hate that, and like I think much of the success that Neo4j has enjoyed has been thanks to our ability to simplify things and just make it it's not that hard. The concepts aren't that hard. You have like rings, and then you have arrows in between the rings, and they have some stuff, like, come on, it's not that hard, right? And so I avoided the word ontology. Ontology is really coming back right now, and I think it's thanks to AI and LLMs, and honestly, thanks to Palantir. I think those are the 2 drivers of that, actually, right? But if I then think about kind of shift where it used to be like singular systems, and now our agents span multiple systems. Okay, if you just have one application with one database backend, you have your ontology. It's like expressed in code. It's expressed in the schema of that database, right? Now, more often than not, we span multiple systems. So that and making it constructing it such that you can compute just becomes even more important, or like way more important than it was before. So those are the 2 kind of practical skill sets, like entity resolution and then ontologies, that I think are more important now than it used to be.
Wee, I love this. Okay, so then picture this, right? We're an engineering team. We have developed a context graph. It's up and it's running. So I'm wondering, what is each of your visions for what the future of this space looks like, right? What does the future of context graph look like? If you can not even predict, but what would be your ideal future of the conversation that's happening around context graphs?
I think the ideal state is that it goes away. That's about it. Everyone just knows that in order to make our AI systems, whatever we make, or whatever, make them work in reality, you need to somehow make the institutional knowledge and all the real world decisions part of it. It's not even a discussion, that's just what it is. It's like, do you do unit tests for your code? Well, like, no one talks about it anymore. It's just part of the hygiene of writing AI capable software. So that would be my take.
Yeah. You have something at the tip of your tongue, Will.
Yeah, I mean, I think Emil's onto something there, right? That like if I spend a lot of time thinking about the interplay between agent memory, knowledge graph. Now we're talking about context graphs, and specifically in the AI space, right? With AI agent, memory is like such an important piece, right? It's the essentially like the knowledge, the background, the library, if you will. Sure, I like that. That's a good one. And so I think, yeah, like kind of reading Emil's point, like ideally that everyone is just using a context graph as part of the AI agent memory, as part of the library that they're building. Yeah, I like that.
So I want to make sure that, number one, again, we have time for questions. So please feel free to, I would say, either put your hand up if you do have a question for a member of the panel, and my colleague Yolande will come around with a mic for you. And I'll just ask one last question to the panel, just to see where people can learn more, right? So I'm wondering, from all the research that each of you has done in this field, the years and years of research, right? What is either one piece of research that you think was pivotal to your understanding of context graphs? Or I would also ask, then, what's a place that people can go to learn more from your perspective?
For me, it was building one, like just getting hands-on, like okay, everyone's talking about this. I have to see like what is this really when I go to actually like build one. So that demo that I showed, that context graph demo, that was kind of my my first like hands-on keyboard experimenting, and that was like a really good learning experience for me. And that's kind of I think true for me. And maybe that's talk about learning modes and sort of thing. Like after I read a paper, it's like okay, I want to like build that. How does that actually work, right? And so I guess what I would say that like a resource to learn more would be go to the demo app that I showed. It's like contextgraphdemo.vercel.app or something like that. And there's a blog post. The code. I tried to put in a lot of like explanatory information about how it works. So if you're similar hands-on type, that's a good approach. Like clone the repo. Get it running, modify it for, I don't know, maybe a manufacturing context graph, right? Instead of financial services, maybe see what's involved in that.
Yeah, I totally agree. Just try. The barrier is now lower to build such context graph. So trying is the best way. And so something that is pivotal, I think, is being able to evaluate the impact of your context graph on your agent. So just pick an idea where you can evaluate the results. It can be code, for example. You can just run the code and see if it works. Take something that you know, maybe in your life or in the work, and build a context graph, evaluate the results, modify the context graph, and see the results on the outcomes of your agent. That I think the best way. And so there's a lot of documentation now online to build such context graph easily. And the demos, POCs are not very quick. Production is, there is a big gap, but at least to try and understand, it's easy now.
For me, it was just like Will. I was like, same thing. Just build it and see where I fall down until I get it right. And so that was it. I think for me, though, my next thing is what I really want to do is dive into the PKO website and see if I can sort of become more academic about this and less, not that I don't want to draw circles and sticks, because I like that part of it. It's great for explaining, works well in the enterprise, everybody understands it. But having a little bit more academic understanding of it is, I think, probably worthwhile.
You're saying less vibes.
Yeah.
Less vibes, baby.
I'm a nerd, and I believe in research and building on prior art, and so there's a wealth of knowledge out there. I will say in the GLAM space, libraries and archives, like this is not new hat. There are networked, there's actually networked procedural ontology systems that exist right now that connect worldwide libraries and archives, private, and so it's been done. So I do believe in also studying the work of others and really being able to derive and point and cite to other sources rather than reinventing the wheel. Vibes are okay, but if you're serious about building, I think it's important.
For me, honestly, it's Will's blog posts.
Yeah.
Like they're really freaking awesome. And like the blog post, like the Lenny blog post, and so there's a couple of amazing blog posts by this guy about context graphs. That's all you need. That's all I needed.
That's right.
I'll second that.
If you all saw me come in, side note, and Will knows this, I had a stack of research that they had done based on, so that we can have an intellectual conversation about context graphs. And so, yes, I also would say that those blog posts that everyone has written, right, blog posts, other research as well, have been pivotal to better understanding both the world, but also like the potential of context graphs, and not just the term itself, but the concept behind it. So, okay, so we're going to open this up to those who have questions. See a hand, so we'll go to him first.
This question's for Will. I don't know if this was supposed to go to me, but I've got it now. This is for Will. The whole agentic memory, is there a practical way to like drop this in almost like as a plug-in to an OpenClaw and have it just like learn context? Is anyone doing that yet? It seems like an obvious fit.
You're specifically asking about the agent memory package that I
Yeah. Like, could you have an OpenClaw agent essentially build out its own context graph just as you use it, such that it would perform better in a way that would be like plug and play?
I haven't, but I have a spare laptop in my room. When well, we'll play around this evening and see where it goes. It's a great idea.
That's right.
Search for the Balmer peak area.
Hi, well, thanks for taking your time to enlighten us on all these topics. Really appreciate that. I lead finance systems for my team, so basically helping finance go from sales wants to do something, engineering wants to do something. What does that all look like on a P&L or balance sheet or cash flow statement? So in that sense, finance runs the business really and makes all these decisions from a strategic perspective. So when you talk about tacit knowledge, like finance is really ripe for that in a big way. So I'm trying to think, how do I transform my team's way of getting to the decisions they need, and also just going from data to insight at speed. And the LLMs coming through was a big part of, hey, how can we use this and plug it into our process in a way that still helps us maintain accuracy and flexibility in ways we do. So I read Seth Early's book on ontology, and that really blew my mind, which is why I'm here. So I'm curious to know, like, especially for Jessica and Yann, when you step into spaces where businesses are trying to maximize the use of AI, one, how do you go about, we have nothing, and two, we have a context graph, and we're deploying LLMs, and we're really reaping the benefits of AI? And how do I bridge you've got your process, which you've been working over 25 years, you're bringing a high-level automation. How do I bridge the two? Lots of questions in there, but I'll just let you take it whichever way you want.
So the question is, how do you explicit the processes?
Let's say I have very little documentation from a process perspective, from a taxonomy perspective, from an ontology perspective. How do I get going on this journey? You have a perspective, she has a perspective, and what do you tend to see with your customers if you step into these space?
All right, you want to answer? Yeah. I think in a lot of cases, as you mentioned, the processes or whatever are not explicit. So what you want is the pipelines that create the graph to understand, as you have explainability into the graph, what led to the outcome of the agent. So it all brings back to evaluation. If you are able to evaluate, to say, I don't know, you have a customer support agent, you are able to evaluate, is the ticket solved, the customer happy? You'll be able to go back to the process that happened to do that. And then you can phrase, become deterministic, and in the end, it's a workflow. So you learn the processes along the way through evaluation. So that's why I suggest to all, if you just pick an evaluation framework that you can have, and it will learn the trajectories to do so.
I teach something and have a framework called the ontology pipeline that methodically moves from a controlled vocabulary to a taxonomy to a thesaurus to an ontology to a knowledge graph. It's iterative. And so again, I'm going to tell you that it can't be automated, because if you don't have the words and the language and you don't even know what you're trying to capture, it has to start somewhere. So I've worked with financial service companies. It's not easy, but there's different vocabularies. People have different ways of describing things across an industry. So again, while we want AI to automate things, if we don't have the foundations, it's not going to be 100% reliable. No offense, but like then when you get to evals, you don't know what's missing necessarily, because you don't even have an idea or capture of your data.
The point is, since we are using graphs, you know that what you don't know, you can know that the data is missing because you don't have the causal link to do so. So if you are able to evaluate, and that's a key point, that's why I mentioned if you have some verticals, there are now some horizontal components to do that. If you are able to evaluate, you can always go back if you're using a graph. If you're using RAG or something like that, you won't be. And that's why also I mentioned, try to use some maybe verticals at the very beginning, where it's not necessarily language, it doesn't have to be words, it can be code, for example, so that you can just run code and understand what is missing, for example, or what didn't work. So you have lots of type of data. It can be tabular data, code, it can be words, but let's try everything and evaluate the results. You'll be able to come back to what's missing.
Yeah, so we have something in the semantic world, in the knowledge management world, called competency questions that come from ontologies, and it's what you create. It's similar to evals in that you create questions that are what you want, what kind of answers do you need from your data? And so ultimately what you're doing is you're creating that framework that helps you structure and determine what might be missing. So I think similar to evaluation frameworks, but I do think that needs to be led by humans. I hope that answers it. Yeah, good, okay.
Hello. Hi, thanks. Wonderful panel. My name is Maria, found Nova. We're using unstructured data from like Jira and GitHub to find the R&D projects. And Neo4j have been using it since like 10 years ago in my thesis. And I'm glad to see that it's trendy again and that there is a new take and the use for AI basically world. I'm wondering if we are seeing that context graph is a new take on a knowledge base where you also have decision trees or decision trees. What are other ways you see to keep the graphs trendy? And then what are other things you expect to see in the graph over the years as we go and use agents in other worlds and domains? Because I think decision traces is just like one type of knowledge we can see. Do you see other ways to benefit from this? Thank you.
I mean, I see a million different. I mean, like, I do feel like the context graph framing was narrow because I do think it expands out to workflows. But it doesn't necessarily capture workflows, right? The thesis of context graphs. But in fact, if we start talking about all these different types of graphs that can exist, you're again proposing that knowledge exists in isolation, right? So we've gone down this road before, so you could have like an attribute graph. Does that make sense? Like for an e-commerce situation? I think that we start getting into dicey situations in sort of fractioning or bifurcating our environments, but maybe that's what's needed. Maybe it is, creating more of a networked graph. Maybe that's what will emerge, is a networked graph type architecture, which is not bad. That's my answer.
Yeah, it's a great question, and I think it'll be very hard to find something that is going to emerge over the next 10 years that someone hasn't done over the preceding 10 years, right? Like you look at the context graph and it's like, this is so great, it's new stuff, except in the Neo4j kind of user community, there's a ton of people who've done similar things for a long time, right? But it certainly reached critical mass over the last kind of 3 to 6 to 9 months, and then it emerged and it got a name and became very popular, right? And so I think everything that we're going to see over the next 10 to 15 years will be similar to that, right? Which is, okay, now there's enough kind of focus on it, right? That it emerges out, gets a name, becomes in vogue, more people start doing it, but there's always then going to be people like, I did that 10 years ago, you know, that kind of thing, right? And they're going to be right about that. So I don't think there's like a completely net new novel thing, but certainly there's going to be more trends and more kind of terminology around it. So that's probably how I see it unfolding, would be my guess. And thanks for being a user for 10 years, by the way. I love that.
I also used Neo4j for my master's thesis as well.
Thank you for that, Will. I appreciate that.
That was my intro essentially to Neo4j. One thing that I wonder about, you know, your question was sort of pointing out like, hey, there's this renewed interest in graphs because of AI, and you know, Emil was talking earlier about like Neo4j's success largely lies in its ability to simplify and make graphs accessible for everyone. What I wonder now is like, does this renewed interest in AI and AI tooling, does that leave opportunity to introduce some of that complexity, right? So you talked about like ontologies as being a source of this complexity and the hesitation of sort of dive into that in Neo4j. I wonder if in this renewed interest, are we going to see more complexity added?
I have so many thoughts on this. Well, I mean, Martin Fowler had a great treatment 20 years ago, 30 years ago around essential complexity versus accidental complexity, right? And essential complexity is, okay, it has to be there. Why? Because whatever we're trying to do is intrinsically really complex, right? I think that is, when you say, will AI introduce more complexity or drag more complexity out of the graph world, I think some of that will happen. The essential complexity. What I've always had a problem with is the accidental complexity. When we take fundamentally simple concept, I mean, sound so fancy and so sophisticated and so hard, that I think is raising the bar unnecessarily. Right? Hope we're not going to see a lot of that, like that accidental complexity. But I think ontology is a great example, right? Like again, I've been striking down on that word for, you know, many years. Like why? It's a schema. Come on, make it too sophisticated. Now I'm a huge fan. I'm using the word all the time. We're going to build in way more ontology capability into the product going forward. It's a key area of focus for me right now in 2026, right? Because the world has changed, right? So hopefully that's essential complexity and we're not inflicting accidental complexity onto the world. So that's like how I look at that.
Oh my God. Yeah. Let's see if it works. Okay, to the panel, in the context of context graphs, how would you define reasoning? And how would you compare it with purported reasoning in LLMs?
I can go first and say that I cannot define reasoning. Whenever I've tried to define reasoning, I've fallen short.
But in the context of your products, let's say.
Yeah, I mean, you mentioned RDF before, right? This used to be like one of the things that the RDF community talked a lot about, like there's reasoning included in RDF. And usually, like whenever you kind of try to pin it down, what do you mean with reasoning?
Right.
It was always some version of hierarchical relationships when you say that. You know, whatever, this is an apple, like some subclass of apple, and apple is a fruit, so then transitively, this thing is a fruit, right? So that was the reasoning. Like, that's a query. Come on, you don't need to call that reasoning, right? So I think what reasoning is very hard to uncover. I think very mechanically. Practically comes down to getting answers out of your data. When you say in the context of our product, I think it comes down to getting answers out of your data. Typically, including queries that are more sophisticated and harder to do out of other types of databases, like a relational database. That's usually, but again, I started out by saying I can't stringently and strictly define what reasoning is.
Yeah, I think reasoning is definitely tough to define. So maybe to take a sub-case, so if you take agents, what is reasoning? It's basically making decisions. So if you have multi-step things, agent needs to decide at some point. For example, should I escalate a ticket? Should I take a path or another one? So it all boils down to decisions. And the key question is, who's making the decision? Are you letting a language model do the decision, if you use RAG, GraphRag, or whatever? Or are you making the decisions inside the graph, so expliciting the workflows to do that? So I would define reasoning in the case of agents as decisions rather than reasoning.
I have my opinion about reasoning. I would take it a step further. It's not so much a query. Reasoning happens by way of rules. We apply rules. And that's something actually that the original context graph article mentioned was rules, that we can't make decisions without rules. And so one thing that RDF, and not just RDF, but ontologies in general do is they introduce rules, which therefore introduces a certain logic, and that becomes therefore logical reasoning. And you don't, ontologies themselves don't present logical reasoning, just so you guys know. It's, and for those that do know, you usually have reasoners, and it just so happens that AI is fabulous at reasoning. They don't need reasoners, but generally knowledge graphs are an architecture. An ontology is a part of that architecture. They enable reasoning, but there's a selection, a number of reasoners that will support reasoning over your data, which is essentially respecting the rule base or the rules that you've encoded.
I think the second part of your question is really interesting, right? Because you're pointing out this idea of like purported reasoning by LLMs, right? I think there's been some research and indication that sort of goes through that reasoning and responds with its like thinking steps. That's not actually what's going on in the weights. It's just sort of like post-rationalizing that, which I think is really quite fascinating. I think if you have though some grounding in the context graph and the knowledge graph to accompany that like post-rationalization, you can capture that as a reasoning trace a bit better. But I do think that's fascinating research, that like what the LLMs are saying that they're reasoning about are maybe not necessarily what's actually going on in the weights. It's kind of fascinating to think about.
If I tie this back to sort of my worldview, I was like with Emil, I didn't think of any of the work that I was doing was like reasoning. It was actually querying, but I was trying to query in such a way that I would provide enough information for the LLM to do a reasonable set of reasoning kind of thing. It was like not so constrained, not so closed, but so that my stuff isn't so rigid and fragile. But to me, it's not reasoning that I'm doing, it's the querying.
Hi, thanks for the sharing. My question is related to the graph. So I was thinking about the context or the knowledge, why it is a graph. So if it was helping like a decision tracing, it could be a trade or it could be trial. But just the way we organize the knowledge, it just in my so my question is like, what if it's not the graph, what else it could be, per the data structure perspective? Yeah.
I can't even think of one other. Look, I think all of these data models are what's called isomorphic, right? Which means you can take data in one of them in a relational database, you can transform it into a graph, you can transform that into a document database. And so fundamentally, like you can express data in all of them. It comes down to like, what do you want to do with it, right? And I think many of the things we've seen here today is about kind of walking that data along relationships, along connections. And once you start wanting to do that, that's entirely doable with other. It's just harder. It's just more friction, right? So I think everything you can do, and it's just a matter of how much time and money you do to throw at it. But many of the things that I have the best mechanical sympathy with the graph model, right?
Yeah, I think the point is rather not how you do the data, but how you can leverage those. If you take text, for example, you can use complex things, accidental things, RAG, things like that. So the main advantage of graph is you can just walk through a graph. That's one theory on how to leverage the graph into an agent. So that's a way to leverage those data.
Sorry, I think I broke. Oh, no, I didn't. I think what's fascinating, there's more than a 10-year project that was done within the library systems. That's the linked data project. And yeah, linked data in and of itself is a graph type structure. But when you start looking at some of the nuances of, it's not a traditional graph structure. So so the linked data project was a partnership with Google, Amazon. It's still kind of going on. It's a new way of thinking of things where you basically use URIs to link records. And within the URIs, you have encoded structures. I think that's a really interesting and compact, efficient way to encode knowledge within a linked data HTTP URI structures and linking those in between. I think it's super elegant, and you can pack a lot of information, and then you can manage the expansion and contraction of knowledge at scale. It's definitely something that's cool.
I think it's just a graph, probably. Sounds simple, but it's just how I think about this. I can't even think of another way to just sort of arbitrarily express things other than to just draw something, connect it to another thing, and if you don't like that, then erase it and try again, right? It's just, but at the end of the day, I'm just building a graph, and I can't think of then another way. How you store it, at the end of the day, who cares? But the way you sort of abstractly think about it is just, that's how I assemble knowledge in my brain. And I'm not as smart as the rest of these people, so there you go.
But yeah, we all think in graphs, right? I mean, that's what's amazing about graphs is you go to a whiteboard. We call it the whiteboard model for a reason, right? I mean, you're able to represent the way that you're thinking, and with graph databases, storing, modeling, querying your data. That's all the same data model. Like how we think. I think that's super powerful data model.
Hi everyone. So my question is, what do you think is the potential of graph theory as a science to revolutionize the field of generative AI, right? Like, how much potential does graph theory as a science have to revolutionize the field of generative AI? For example, if we couple graph theory with neuroscience research and try to model the human brain in terms of different graphs, and try to automate those processes using large language model as a reasoning tool and so on, because a lot of the advancements or leaps, you can say, are all based on advanced graphs, right? For example, the gateway and OpenClaw and so on, all the queues and whatnot. It's more of going towards more complex graphs, right? So yeah, we'd love to hear your take on that.
Happy to go first. I think there's a very intimate connection between the graph representation of data and LLMs in particular. And I think the first wave of that we saw with GraphRag, right? The second wave of that was all the agentic memory stuff. I think the third wave is context graphs. And when we sit here a year or two from now, there's going to be wave 4 and wave 5. I think there's plenty of ways up and down the stack where that marriage is going to kind of expose itself, right? We've just seen the first 3 of them, and there's going to be plenty more. That's my view, at least.
Yeah. I think it's interesting to think, I mean, in terms of LLMs, and I think that your question is aiming towards how it will advance LLMs. Is that correct? Yeah, yeah. I think it has the opportunity to, if it's structured correctly. I think that we need also the reminder that most of these foundational commercial models, those companies are also very human. They're software companies that also have and deal with a lot of the same issues that we all deal with in our own technical spaces. I'm sort of reminded of that often. But in terms of advancing, if we look at sort of the structure of the most frequent and biggest or highest volume of training data and the structure of that data, Wikidata is one of them, Google Patents is another one. Those actually happen to all be ontology graph systems. So when we actually look at the training data that goes in and that has the biggest influence on the success of a lot of these models, I think there's more of a focus in that area. And I think the quality of the data is coming out. There's another piece of research that I've been involved with about provenance. You know, the one problem is that there's a lot of improvements that need to be made on the parametric layer in retaining provenance and citations and sources. All of that is stripped out of the data at training time. So right now we're all like on a wing and a prayer, you know, hoping for the best on the retrieval layer, right? And so I think that's where the most, the most interesting advances are starting to emerge. Hopefully. Hopefully.
Okay, everyone. So I don't have a mic. Well, thank you. Oh, you both are so kind. Thank you so much. So I don't. Now I have a mic, but I know we did have two last questions. However, we are getting very, very late, and I want to make sure that if people do have questions, so what we'll do is a couple of us might be able to stay after and ask, and so you can ask your questions directly to the speakers. But I want to make sure that we're respectful of everyone's time. So we're going to end the conversation here, and we want to thank all of our speakers for coming out today. Thank you so much. Beautiful. And we will see you all at the next Context Graph meetup. And especially if you look on Lumo, we have our next Graph Exchange coming up in March. So we look forward to seeing you all there. Please feel free to connect with us and connect some dots on your graph. All right, we'll see you guys soon and come up with all your last questions. Thanks so much.
Thanks, everyone.